All right, example 1. We get to play with trig ratios from a terminal point. So basically they're going to give us a point and they're going to say figure out the all the trig ratios from there. So it's kind of fun. It's not so much with factoring. Factoring sucked a little bit. This stuff's a little bit more straightforward, so it's kind of entertaining. Plus we can draw a picture of it, which is always good. So let's draw. Picture P. It's at 2 and -5, so I go over to 2 and down to -5, and I draw my little dot right there. This pen is terrible, I apologize. So this is at 2 and -5. So if I draw my little terminal arm coming out here, and I draw my little dot, showing you where the triangle is, you could kind of get an idea that this is 2 and this is 5. Now, when we're trying to find this angle, I don't really care if the sides are negative. You're solving a triangle. You're finding the angle here. So just look at it like a triangle. Don't worry about whether it's negative or positive when you're trying to find the angle. Just go with it. But that's only when you're looking for the angle. Otherwise, yeah, you kind of got to keep track. Meanwhile, what we've got is, we know what quadrants it's in. We know where it's situated relative to standard position and all of that. And we can use the 2 and the 5 to find the angle and get it nailed down. So the first thing they ask for, though, is the trigonometric ratios. So we need to know the sides. Now we know that x is 2. And we know that y is 5. -5. We should probably keep it in the negatives for the ratios. But we don't know what this side is, so what's that side? How could we find it out? Oh, Pythagoras. So we're going to go that r is equal to the square root of y squared plus x squared. For this particular equation, we've got 2 squared plus 5 squared. Does it matter that it's -5? No, because it's going to be -5 times -5, which equals a positive anyway. So just plug the numbers in. Absolute value is fine. Which means it's going to be the square root of 4 plus 25, which gives us square root 29. Now 29 is a prime number. There's nothing you can do with that. It's done. You can't simplify it, you can't make it a mixed radical, there's nothing. It's just square root 29. Beautiful. Love it. So, trigonometric ratios, pretty easy stuff from here on out. I just have to remember that sine is y over r. And for this, it's 5 over root 29. -5. Now, cos is x over r. Remember that we're always using this same setup at standard position relative to x, so they're always going to be the same. And we can use x over r instead of adjacent over hypotenuse. And so we just plug in our values, 2 over root 29. And our last one would be tan. And tan is equal to y over x. And in this case, it's -5 over 2. And so if I wanted to find my angle, I would probably want to use the simpler one, which would be tan, because it doesn't have a root in it, and it's the values that they actually gave us. So I could go tan, second function, 5 over 2. This is where the negative doesn't matter, because it's just a triangle that's 5 by 2. And in my calculator, I better make sure I have second function tan. And 2.5, I'm just cheating a little, 68 degrees. Usually your book will go to either to the nearest degree or the nearest tenth of a degree. I'm just going to go with 68 degrees here because I'm a bit lazy. And it's also 68.2, so like, whatever. So this is 68 degrees. That's not the angle though. That's the reference angle. It's the one that's stuck to the x. standard position, that's the angle. So since it's in the fourth quadrant, you can go back to the last little bit we did on the construct understanding, and in the fourth quadrant we went 360 minus the reference angle to get the actual angle. So we'd have 292 here. That makes sense? Looks good to me. Which means that our angle from standard position, which is here, and counterclockwise all the way around to the line, is going to give us 292 degrees.